Like the combination of condensers, you see the combination of slabs is also quite fascinating. Slabs could also be connected in parallel or in series, and there is a well-defined symmetric formula for the combination of the slabs. If we introduce two slabs in this manner, we would say that both the slabs are in parallel. And whatever the charge you will be giving to this positive plate, if you give the charge positive, it becomes positive plate. Now, the electric field that we produced here will be from positive to negative. You might suppose that there are two condensers and those condensers will be considered in series combination. Why? Because this charge will no more be transferred. Whatever the charge will be induced here, that will be because of induction only. So it is just like series combination. The two condensers will have the capacity A K1 upon D by 2. This will go over to numerator. Similarly, C2 also, it will be 2 epsilon naught A K2 upon D. The combination of condensers shall be taken as a series combination, and for that 1 by C, 1 by C1, 1 by C2. This is 1 upon C2, you see, this is D upon 2 epsilon naught A K2. Likewise, D upon 2 epsilon naught A K1. And here it's 1 upon total, it will be D and epsilon naught A K A epsilon naught A K. All gets common and cancelled. D upon epsilon naught A throughout gets common and cancelled. What remains is here 1 by K, 1 upon 2 K1 plus 1 upon 2 K2. This is mostly preferred in this format, 2 by K, like this, which you can generalize by using n slabs of this type. In that case, it is going to be n over k equal to 1 upon k1. It will ultimately go to nth term. Suppose you are having only 2, then in that case, k becomes equal to 2k1 k2 upon k1 plus k2. This was the combination, parallel combination of the slab. Now here the two slabs have been placed horizontally one above the other. The two slabs would be considered in series, whereas the two condensers will be taken as parallel because their one side is positive here. For both the condensers, they would be considered parallel. In this case, you see, if we consider the capacity of one condenser, that's using only half of the area, it's going to be epsilon naught A by 2 K1 D. Similarly, C2 is epsilon naught A 2 K2 D. And because it's a parallel combination of condensers, in that case, you would write here epsilon naught A, epsilon naught K A upon D. This will be K1 will be in the numerator, epsilon naught A upon 2 K1, it will be D, epsilon naught A, K2, it will be D. So this could be written as epsilon naught A, K1 upon 2D, epsilon naught A, K2 upon 2D. This simply is common throughout What remains here is simply K equal to K1 plus K2 by 2. If there is n number of condenser, then in that case this is equal to Kn upon n. Now, in order to make the mixed combination of the series and parallel both, we are having here two options. Here we have chosen two parallel, one series, and in this case two series, one parallel. Here the equivalent will be obtained by this method. First you will consider the resultant of these two and then you will combine with the K3. In that case you are going to have equivalent value of K. It's given over here. Similarly here also, because we have derived the method same we are going to follow, then first you will consider C1 and C2 here and then you will combine with K3. Result is going to be this one. This is the combination of slabs.